guys, welcome to Bar Z. My name's Stan, and I'm just voiceovering a little clip for you here. I'm doing some plunge grinding, and I'm taking some squares that I make down to a specific depth, and then I'm going to start doing a step over. And right now I'm just showing you getting across them and getting them cleaned up and getting down to the proper depth. So this is just a simple plunge grind here. And we're just taking little bits at a time and flooding it with coolant. But then I'm going to show you the step over operation after we're done. And we're actually removing quite a bit of material, and on thin parts you can't do big step overs. You have to reduce your contact surface of the wheel as much as you can. And my typical method is to bring it down to depth and then start doing a 5,000 step over. And even on squares this big, you know, these aren't even the biggest ones I make. You know, you just can't do the big step overs, and you need to really take it easy on the thin parts. You will warp them and cause discolorations. And I think I'm to depth, and we're going to start doing step overs here. But you can see I'm doing 5,000ths per step. Now, if you do the math on that, just getting across those squares is going to take quite a bit of time. But here, let's cut in a second and go towards the end of this thing. And here we are, 20 minutes later, just coming off the part, still with the 5,000 step overs. So, you know, I could train a monkey to do this and just feed him bananas. Or, you know what, I could take the grinder apart and try to come up with something else. So there's a whole front end of my machine sitting there. Let's see what we can do with this. Hey guys, welcome to Bar Z. My name's Stan, and today we're doing a little modification on the 618 surface grinder. Some of you may recognize some of these parts. This is the snout on the technically, I think it's called the Z-axis, because you always use the spindle as a point of reference. I've got the dial over here, and it's got the indexable wheel on it, and everything's just came out of the sink. Everything got washed. But we've got the snout, and we'll go through them piece by piece on everything we had to do. We're going to be installing a little stepper motor on this axis via a couple of small pulleys and a timing belt. Very miniature. Alright, and this offers me, between that stepper motor, the stepper motor goes on the small sheave, and this is going to go on the actual hand wheel. This offers me a 2.5 to 1 reduction. The stepper motor came in at, I think it was 200 steps per revolution, and after the gear reduction we were at 2/10 of a thousandth per step of the stepper motor, after I did all my math and everything. But we've got the snout, needle bearings out, and the little seal out. They drive out with a brass drift very easily, and so the snout's clean, and we've got dowels. That's what pins it when we install. So we've got it completely stripped. Our hand wheel is completely stripped. The knob actually drives in. You can it very easily drives out with a drift from the backside to support your work very well in a vise. And the index wheel, the retaining screws are out. That's what holds that in, and all that's stripped down. Now what we need to do on this one is right where this is, that needs to be right there. All right, so not too bad. We're going to turn this down, and we're going to bore that and slip it on. Over on this other side, on the snout, I'll show you the profile of that. I've actually recorded the profile of that with the bore and more importantly, the distance between the bore and this flat. See, it's got a flat in it right there. So I've recorded that. And what that flat is for is my little pointer for the indicator wheel. That wheel ends up right there as so. So I want to retain that, but we have to turn this end down here to mount our stepper motor. Our stepper motor is going to be underneath, so this taper, the first inch or so of it, we're going to turn it down and we're going to be losing this flat spot, but we're using a chunk of aluminum and we're going to put it right back. So after this is slipped on, again, we've got a place to mount our pointer or our witness line, whatever. So we've got our material, and we're ready to start off. These are both 4-jaw jobs. This has to get turned down, so that's going to be some 4-jaw indicating. This needs to get turned down. That's an odd ball. That's an odd duck there, so that needs to get 4-jawed. We got a nice machine surface here to index to, and same with this one. This has been machined here, so we've got a nice index surface there. So we should be able to index, and we're going to be using the center bore on both of these to index to. So that's the modification. I guess I could take you over and show you the machine, what it looks like. It's just a raw shaft sticking out with a just a bearing that drops in here, a ball bearing, shielded, nothing fancy there. But shielded ball bearing there, and then you got your needle bearing. That little feller goes in right there. All right. So let's run over to the machine real quick. I'll show you that, and then we can get to getting all this stuff cut up. Okay, like I said, nothing too special there. You got a lock nut. It's got a little kind of a castle serrated washer. I don't even know what you call it. But as of right now, I can just pull this shaft and the whole table comes out. So that bearing and everything gets pinned in back behind that that snout. So you can see I can just start unscrewing that lead screw, and she's just gonna come all the way out. So, but nothing fancy there. 3 bolts holding it on. All right. Okay, let's get to cutting them parts. Okay, well, we got the part in the 4-jaw, got it indicated in. It was kind of an unusual thing to deal with. And what I'm starting off with here is a negative tool. That's a CNMG, because we've got just a horrible interrupted cut, and it's like someone coming around and swinging a hammer against your carbide. So, you know, I chose negative tooling till we at least get it somewhat round. I will not be able to finish the job with the negative tooling because I can't get in tight enough to the live center. That tool's just way too big to sneak in there next to that live center. So we're just getting a little round with the CNMG, and then we're going to switch over to a neutral tool presentation. Okay, here I've switched over to a neutral tool. That means the top of the tool is dead flat. And you see it's nice and sharp. I can get in there tight to that tailstock center and do my work. And for the most part, it's round. We got rid of the really bad part of that thing coming around and hammering on the carbide. So we're going to finish this up with this tool here. We are taking this diameter to 1.250. So let's get through this. Okay, so we're finished up with the nose. I've got this turned down to 1 1/4, and you can see we really didn't take that much material out of it. See if it'll focus on that. No, it's not going to focus on that. So it's all right. So it's turned down 1 1/4. The 2 holes for the pointer were through holes. So I'll probably end up running a little set screw down in there with a little bit of Loctite just to plug them up. All right, so that's this. Let's move on. All right, now it's time to move on to the hand wheel. The hand wheel doesn't have an interrupted cut for the most part. It's a raw casting, but I felt really comfortable with the neutral tooling going through that. And we're taking this one down to 1 inch. This is for our synchronous sheave that has to slip over this. So this is going down to 1 inch OD. So let's get through this. Okay, so we got the hand wheel done. I went ahead and turned it down to 1 inch. There's plenty of meat left. It's only a 3/8 shaft that sticks out of there. It's a tiny little shaft. Tons of room for set screws. And essentially this is going to allow me to slide my sheave on there, tighten these set screws, and still align my the sheave after the lower set screws are tightened, because remember we've got another sheave going over that and blocking these holes. So that's the hand wheel done. Okay, next up we need to bore our sheave out to 1 inch. So pretty simple operation. Okay, well, we got the hand wheel put back together. We got the nose cone bolted back on. Pins, I re-greased the bearings, but now we're turned down here. And we've got the sheave on, slipped over the hand wheel, and it's currently loose. I'm doing this with one hand because I'm holding the camera with the other one. And you'll notice, where is it? There it is. There's a hole right here in the sheave. And what that does is I'm lining that up with that Allen set screw down below. So you slip your Allen wrench down that hole, tighten one, turn 90 degrees, and tighten the other one. And then you can proceed to put your other set screws in here to pin it to the wheel. So you've got two set screws on the actual sheave, and there's two below the sheave to tighten the hand wheel onto the shaft. Okay, but everything's looking pretty good up to here. I still got to make a mount that slips over here and clamps to hold the actual motor. But we've got a synchronous pulley on our hand wheel now. All right. Okay, so we're going to get through making our actual clamp. First thing to do is just get a hole in it. That's a 2 by 2 inch block. So it's been milled down on all four sides, 2 by 2 by 1, and it's just a mill finish on the other sides. So now we're coming in with a boring head, and we're boring this out to 1 1/4, 1.250. This is pretty boring. Let's fast forward through this. Okay, so our motor plate's done. We just finished milling the small holes. I'll try to get you to see down there. Those are counterbored and slotted. That's so we can tighten the belt, obviously, and get enough slack to get the belt on. You have to hyperextend the motor to get the belt on. Here's a tip for you DRO guys. You know, if you're going to do a pattern like this, and you know, everyone knows how to do bolt hole pattern on their DRO, you know. But and you know, you just scroll through your holes here to do your bolt pattern. But when you get to, here's my last one, you know, I plunge here at 0, 0, but you'll notice I'm 250 beyond. I wanted my hole slots to be 250. So you plunge, step over 250, move to your next one, plunge, step over 250. So you can make slotted holes based on your bolt hole circle. All right. So that's how I came up with those slots. So there's our motor mount plate. Okay, well, we got all our parts made. I took you along for the ride on a few on a few of the pieces, and this is the clamp that actually clamps down on that little nose cone. So that's the clamp, and all it's got is a step in it, which is the same thickness as that. And this just bolts on, and people are going to say, "Hey, man, why don't you make that all out of one piece?" Well, I'm not entirely sure about the stepper motor. We don't even know if it's big enough. We're going to try it. But I don't want to have to remake the whole thing, so this way I can just slip the motor mount off and make a new one of these if I have to change stepper motors. These just go together with some 1032s. Got them counterbored, and just going to pop one in. And I got another one around here somewhere. Where'd it go? There it is. So these two little fellas just come in together like so. So there's your motor mount, clamp, and the motor mount. And now we can take the actual motor, and somewhere along the line I have to go buy a screw. I lost one of the little screws. They're little tiny metric things, and I don't have one here in the shop. And the reason we're on slotted holes is obviously to tighten the belt, and the hole in the middle is big enough that the sheave passes right through, so we're going to get that sheave fixed before the final assembly. Now I'm stuck. Let's try it this way. How'd that be? Go and get that little dude started. Alright. There's one. Two. And three. And see, now we're slotted there on those holes, so we can go all the way up here to enable us to get the belt on. You know, you got to get the darn thing on, and then we slide it down here to tighten it up. Or that's my theory, so we'll see if we can in fact get the belt on. According to my calculations, it should slip over. These sheaves have a shoulder on them, and you have to be able to slide that belt over. Alright, so that's ready to go on the machine. And then we've got our sheave we made, you saw earlier. That's what goes on the hand wheel. So we have to, the belt won't go over the hand wheel, so you have to install the belt, install this first on the nose cone, then follow it up with this, then get the belt on and tighten the motor. Sounds like a pain in the butt. Let's go see how big of a pain in the butt it really is. Okay, well, we're at the machine, and we've got this is all assembled, greased, and done. We've got our needle bearing in and our felt seal there. We've got our motor mount, and I've got the motor sent all the way in that one direction. So I'm just going to slip this dude on here. And when I tighten that bolt, it'll clamp up. The thing that's nice about this is I can swing this motor in any direction with the belt drive, and it's going to swing around its own axis, so that won't even affect the belt tension. I can swing it to the left, I can swing it to the right. I think I'm just going to leave it straight down. And then we've got our hand wheel, and we have to put the belt on first because the belt certainly won't get over the hand wheel. And what I need to do is find all my set screws through my peak hole like that. And I've got one there and one there. So I'm going to do this and come on here. And we're all the way down. And I should have clocked that shaft facing up. I think I got it. Oh yeah. I'm feeling for the flat spots when I'm doing. There it is. Okay. So that one's tight. Let's get out of there. And now we're moving the table. You know, I can turn this around to my next set screw and go in through my peak hole. There it is. I can tighten that set screw. Okay. And now this is free to move around, and this has its own set screws to clamp it down to the hand wheel. Now let's see if we can get this on the oh, I can swing this up here maybe and do it. That's kind of handy. This allows me a little bit of belt adjustment too. By enabling me to slide that that sheave back and forth this way, I can get my belt alignment. Oh wow, that was close. Well, we got it on there. Okay, and we'll do a rough belt alignment here. You can move. I made it so you can move the motor a little bit in and out too for belt alignment. I think we're ready to tighten there. This is my pinch bolt here. Okay, feels good, nice and solid. And all that's left to do is sneak in. I'm going to move you guys. There, I moved the camera. Now we're to a point where we can get in there, loosen those bolts on the motor. And tighten our belt up. And we're not going to go Mongo tight. I'm just going to pull it down with my hand firmly and tighten these little fellows up. Get in there. There it is. All right. Okay, yeah, we got good tension there. Get in on that one. Yeah. All right, and now we can do our final. Let me move the camera one more time. And see, now we've got belt alignment this way with this sheave, and also I can loosen here and move the motor in and out slightly after we get the motor running to make sure the belt tracks properly. But that's the gist of it there. Look at that, pretty good. All righty. Well, that's part one. Next part's we got to get a limit switch on this on the table and start working on installing the controls that are being built for this. All right, hope you enjoyed this segment. But that is Z-axis control or Z-axis step motor on a Boyer Schultz 618 surface grinder. All right, man. Thanks for watching.